So, thank you for joining us. This webinar is about how to build a synthetic data pipeline for end-to-end autonomy. So, my name is Roger Ordman. I'm the VP Marketing at Foretellix, and I'm joined here today by my colleague Warren Bussin, who's a Senior Solutions Engineer for us on sensor simulation. Also joining us is Itai Tzadok, Senior Product Manager at NVIDIA. He's leading neural reconstruction and real foundation models for the autonomous vehicle simulation. And last but not least, we're joined by Dan Gural, who's head of partnerships at Voxel 51 with a background in machine learning, specializing in physical AI systems and models. And what this is about today, it seems that new technology is being introduced on a daily basis. So NOREX, sensor simulation, data curation, SDG, WFM, it's ongoing. It's coming out from all directions. And we have an interesting webinar for you today. This one should help put these terms into context and show how they complement each other in a synthetic data pipeline. So in this webinar, our teams will show you how vast amounts of real-world data, real-world driving data is curated, how coverage gaps are identified, and how new synthetic scenarios are generated to create good training data sets for your AV stack development. So without further ado, over to you, Dan.
Thank you, Roger. Give me 1 second to share my screen. I'm very happy to be here, and thank you for the very nice introduction. I appreciate it. Heading over here to my slides. Roger, just give me a thumbs up that everyone can see my screen with no issues. Awesome. All right, let's get to it then. My name's Dan. I'm from Voxel 51. We're going to be talking about the first step on how to build these synthetic data pipelines for end-to-end autonomy, which is data curation. Now, if you are working with these type of pipelines, very often whenever you get to this stage, whether you're just starting or you've been in the space for a very long time, um, it's always crucial to have very clean data pipelines going into all of this, especially in automotive. The numbers that I'm hearing nowadays is petabytes of data, right? Not just one, but 5, 10, 15, 50. And how will we get more and more of these petabytes of data because we just have so many cars that are driving on the road now that is collecting data, very dense data. How do we make sure that we're kind of efficiently clearing through this data, surfacing the most important for our models, as well as throwing away all that junk to save on those cloud storage costs, save on those annotation costs, and more. And we're going to be discussing how you can do that with a tool like Voxel 51 today. And very importantly, with the broad stroke curation tools available in 51, understand where in your data set the gaps are that you can then create with synthetic data. So moving on, everyone probably knows this guy. Unlocking the potential of your data is the new key competitive advantage. Why is this the case? The real reason is because not many people are building models today. And when I say building models, I don't mean to be patronizing to anyone here. I'm sure everyone that's a machine learning engineer is still building models in some level. It's just not what it used to look like. We're no longer kind of building the architectures ourselves and kind of putting our layers in the right spot. We're fine-tuning models coming out from open source or fine-tuning existing architectures, slightly changing them. What is not changing here is that no one's giving you all this free data, right? Unless they're NVIDIA, of course. Your data is the new key to your competitive advantage. How well your data is, how well you can find things, how heavily it's annotated, how robust it is. If you have a really, really strong data set, you're going to have a really, really strong model on the end of it, right? However, there's a lot of issues with this. The issues are that a lot of times the data is not as good as you think it is, right? And things fall through the cracks and there's mistakes and issues, leading to about 85% of all AI projects to just fail one way or another, right? That's not necessarily all the teams or all the companies, right? Well, many times you start up a project and it just doesn't end up going the way you hope to. Some key examples from real world examples here. Many of you might be familiar with the Amazon's Just Walkout store system. Whenever they actually deployed it after years of training, it turns out that they had to stick a human in there anyway because it wasn't able to verify about 70% of the transactions just because the AI wasn't accurate enough on its own. Another one is things like Tesla and Waymo, who are constantly putting out more data and reports about the accidents that they've had and the lack of understanding for things like in the past, Waymo had trouble with construction sites, Teslas have had issues reading signs. There's a case where at Tesla, someone just put a piece of duct tape on a speed limit sign, and then Tesla misread that speed limit sign from 30 miles per hour to then accidentally read 80 miles per hour. So these are real world problems that we need to make sure that we're just capturing to understand exactly what these issues are. And a lot of the time that you're spending is just wrangling your data, whether it's in Excel files, S3 buckets, notebooks. I can't tell you how many people have passed me a notebook called like dataset underscore to IPNYB, right? Like it's very unclear and very unclean how people are working with the data today. And a lot of this is causing simulations to fail, for synthetic data runs to fail, because when you're doing a task so complex like synthetic data pipelines, we want to make sure that you have the most crisp and clean and observable data pipeline going into any model that you're going to be running. This is where 51 comes in and helps you. There are four main pillars of 51. The curate, which allows you to find all the issues and malaligned data inside of your data set. Annotate, which will allow you to fix any of those mistakes. Annotate your data, add bounding boxes, 3D bounding boxes, classifications, video classifications, and more segmentations to make your model understand exactly what is happening in your data set, both by humans as well as with auto labeling with agents and more. Generate, which is going to be all of the synthetic data, 3D reconstructions, Cosmos, and more. And then evaluate, right? I think about synthetic data pipelines. I think so much about evaluation of where the hallucinations are, not if there's going to hallucinate, it's just where it's going to hallucinate. How bad is it? Is it enough to be put into production? This is a constant feedback loop that you need to be doing over and over and over again with all these pillars to have the best data pipeline going into your models. And when we speak about that, for 51, it's your data in your models. This is not a SaaS product. You don't send your data to us. The product allows you to connect to your enterprise cloud service accounts, your buckets, your GPUs, everything that comes along with that. You can bring your images, your video, your 3D data, even more. MCAP support is coming in a few weeks here as well. And then all of your own models that you're training, custom, whatever you're doing, all will connect into the tool to help you give the most visualization and observability into your workflow. But the thing I'm very excited to kind of show specifically today in our product is our skills and our agent. All of our skills are open source. If you're interested in them, just go to the 51 repo called 51 skills, and you'll be able to grab any of these skills. And these will plug into all your favorite coding agents, Claude, ChatGPT, Gemini, whatever you're using or you're interested in. Cursor is another one, I believe. But all these skills are open source. You can grab them. And just to show how much we've been refining these and putting efforts into them and continuing to build on top of them, we're really at the point now in our enterprise product where every single feature available in our enterprise product is now surfaceable through a skill in our MCP server. For an example that I'll be showing you here today, um, in our little mock example that we're doing here with Rohan and Itai, first we need to load in 100 scenes from NVIDIA's physical AI automotive dataset into 51, so that way we can start working through a dataset and pretend, hey, where are my gaps? Where are my issues? Where are my samples? So I can then identify where we need to add synthetic data on top of it. I say make sure to use the 51 dataset import skill just to make sure that it grabs it and grab as much metadata and labels as you can. I copied and pasted this exact prompt into my Claude. I didn't do anything else. There was no other further conversations that happened. All I had to do was it asked me to log into Hugging Face. Sure, I did. And then after that, I promise you I did not touch it any more than exactly what I put in this chat right here. And when you will let that run and finish, what we'll see here, if I jump over into our tool, is this physical AI data set fully loaded in with labels, metadata, including time of day, speed, number of LiDAR points, the country, the region. It even asked me like things like, making sure it only loaded in a sample of it. It loaded in 50 gigabytes as a happy agreement. It wasn't doing any more than that. And then sure enough, when we click into any of our samples here, we're able to see not just the front camera here, but all the different camera views from the back, the front, the side, as well as the 3D labels and our bounding boxes and LiDAR points all located in here. I didn't write a single line of code. I waited about 5 minutes for the scripts to be written. I waited another 30 minutes for the data to be downloaded, and all of it loaded in automatically using our skills. So it's a very easy and efficient and fast way to start working with data without having to know how to work with 51s, every single line of code, or even physical AI in general. The other awesome part about this is that you can build anything with these skills as well. So if there's a certain workflow or feature or anything you're interested in, you can just ask your coding agent and it will just build it in and out for you for visualizations, dashboards, automations, workflows, pipelines, wiring in custom models, you name it. We have surfaced the skills in our MCP server that allow you to do this, and I'll be showing an example. This allows you to get to data insights faster using our agent, increase the development productivity, and accelerate and automate and start deploying these agents into your data sets to find these things even faster. So let's look at some examples to that. So on this data set, we can do some fun things here. One of the things that I asked last night, because it takes a long time, is to do embeddings on top of my data set. I used Quen. It's very easy to generate any new embeddings or searches. I can just go to my similarity index, click my similarity index button. You go from here, you can pick what model you want to use, and we can start running with this. Similarly, you can do searches such as a heavy rainy night or a construction site. And it can be a text prompt, it can be an image prompt, a video prompt, depending on the models that you use. And then it will return the number of samples that you select within a certain threshold. So if I look at my construction site, for instance, it will load up that view in my data set across all my different videos. And sure enough, if I make this a little bit bigger here for us, what we'll find is that all of these videos happen at some sort of construction site, right? And if I click into this, we'll get not just the single video view, but we'll get the full 360 video view of all this, how clustered it is with all the different obstacles. You can see just how complicated the scene is. I found this in a number of seconds by just doing embedding searches and finding these samples. We can also do a heavy rainy night. I actually did this one with a video prompt. I saw this first video and I said, ooh, that looks really bad and like really messy and hard to any car or even person to tell what's happening in this scene. If you kind of drive through it, you can see all the rain and refractions on the lens here. Well, I said, well, this is really bad. Let's use embedding search to see if I have any similar samples across my entire data set to make sure we flag those as well. And sure enough, we found 4 more examples that all have this kind of lens refraction kind of look on them from some rain that has hit the lens during this drive. So just a very quick and easy way to understand exactly what is happening here. But what I want to show off before I pass over to Rohan and for actually generating the simulation is using my agent to actually ask and help create a strategy for where my gaps might be. So in this case, I go and I ask at the very top. You can see this is connected to my Claude. Help me understand the weather and time of day distribution of my data set so I can create a synthetic data generation strategy to fill in my gaps. Sure enough, what it's going to run through is going to grab all the different fields it sees on my data set. It finds the countries, it finds the month, the time of day. It kind of rocks through them. You can see all the different tool calls it's doing. It actually opened a panel for me, which is the histogram panel that lets me see things like, oh, we actually only have one country. It's just the United States right now. And when we go to things like time of day, I can see that I have some gaps here. For instance, we don't have that much time of day in the very, very early morning, as well as we fall off in some key times. So sure enough, it actually gives me a little table here and says, hey, we really need a little bit more dusk and dawn footage. We don't have that much. And these are very crucial times where the sun is very low on the horizon. It might be blinding our cameras. It's identified this as a severe gap and something that we should try to fill in. Similarly, you'll also do weather and seasonal based on time of year. That seems to be pretty well distributed, so that's good. But really, right now, the red flag is everything's in the United States, no synthetic data for any other time of data. This is a really great problem for Cosmos to help solve, something like a dawn or dusk, or localization from a United States scene to be something that looks a little bit more foreign by changing the signs or changing the road lines and things like that, are all things that you can solve with synthetic data and something that the agent can just kind of go ahead. And even here, you can see that the agent even calls out some great next steps, for instance, such as, hey, if you let me use a classification model, I can actually tag weather, such as rain or snow, for you. Do you want me to do that? I said, yes, please. We move down here. It kind of goes the whole understanding of the data set. It creates a pipeline for you to be orchestrated over your GPUs. It asks you to proceed. It says yes. It missed the minimum confidence for one of them. I said, yep, let's retry it. And it said, good. Great. And that's going to start generating, and that is now currently queued up and monitoring on my progress right now. You can do this for any type of your automotive data sets. If you already have the weather ones, it'll do this whole really great workflow on that as well. You can just imagine, how well it does. It'll look for misclassifications for the weather. It'll find any low ones such as foggy. And so you can really start to build up this synthetic data strategy and understand where your gaps in your data set are to help kind of make sure you're synthetically creating what actually you need, right? And just scanning through these petabytes and petabytes is so painful and so annoying at times and costly. So being able to making sure that anytime you're doing this inference, anytime you're spending all this money on synthetic data, that you're actually going to generate data that matters. Now, once you know what you need to generate, this is when it's a perfect time to pass it over to a tool like Foretellix, where you can go scene by scene and generate exactly that type of synthetic data you need. So at this point, I will stop my screen share and pass it over to my good friend Rohan to take it away.
Thanks, Dan.
Just Ron, before you do, just to the audience, if you've got any questions, we'll be accumulating them now. Keep them. You can put them through. We'll gather them up and we'll ask them at the end. So feel free to put them in the Q&A box, and we'll be gathering them. Ron, over to you.
Thank you. Yeah, thanks, Roger, for the intro at the beginning, and thanks, Dan, for the great overview of Voxel 51 tools. I will share a little bit about Foretellix. So let me share my screen as well, and hopefully you can see my presentation. No. So just wanted to first start off by introducing Foretellix's data-driven autonomy development toolchain. As Dan also said, we start out from real drive logs, in this case, the NVIDIA physical AI dataset, and we use that to build a data lake, and we can perform data curation on top of that. The whole, as Dan said, right, the very first step in your dataset is understanding what's there. So we're able to do things like temporal scenario labeling, denoise the data set to remove artifacts, and then analyze coverage and probabilities in your data set. And I'll talk a little bit more about what that means. But once we add labels to this data, we can make it a data warehouse and also enable things like curating a data set and triage, measuring coverage and safety and what's already in your data set. And use that to then find gaps in the data set and then augment those gaps, close those gaps with the use of synthetic data generation. So I'm going to go through kind of this whole flywheel in the rest of the presentation. Let me start out here at the top where with temporal scenario labeling and give you an example of what that means. So this is a run from the NVIDIA physical AI NUREC dataset in particular. And you can just please see here, this is the object level view. Here's the raw camera data for the front camera, and we've labeled here different temporal events that are happening and labeled the time at which those events happen. So this is what we mean by temporal scenario labeling. It's a slightly different but complementary way of looking at kind of what Dan described in Voxel, right, where you're focusing on kind of image level search. Here it's event level search in your logs, and it's also a very helpful way of distilling down what's contained in hundreds and thousands of drive logs across your fleet of data collection vehicles. And then one of the things that this enables is also a very fast database search on finding what events happened in your data set. And you can also use this to kind of search for combinations of events that are happening. So in this case, we're starting out on the Panda set, and we want to find cases where the ego vehicle is traversing a junction, and it's also very close to a VRU. And we can set the order in which we want these events to occur, whether one should happen first or the other, or if it doesn't matter, we just want any combination of those. And like I said, yeah, you can find any combination of those, and you click the search option, and you'll get a list of scenarios that match this combination. So this is a super helpful tool to understand what's already present in your data set. But the other side of that is what's missing from my data set, right? What are cases that I want to find where there's gaps in my data set. What am I missing? So let me quickly jump here and kind of drill down into the full physical AI NeuRec data set from NVIDIA. This is with the 26.02 version of NeuRec. I've ingested them all into Foretellix's F-Manager tool where we can identify where there's gaps. And this is a pretty small data set, so obviously there will be some gaps, but I want to drill down into one in particular and focus on vehicles merging in front of the ego vehicle here. And there's a lead vehicle that's cutting in front of the ego. And as you can see here, there's a gap in this data set where there's no vehicles cutting in front of the ego, but with a speed of 20 to 30 kilometers per hour. And this might be a gap that you identify in your data set, right? And you want to use synthetic data to fill that gap. So Foretellix tools actually have the ability to help you with that. And it's using a tool that we call the scenario designer, a scenario editor, scenario designer. So what you'll see here is a different log from the NVIDIA physical AI dataset that we can modify pretty easily in order to fill the gap that you saw before, forcing this red vehicle here to cut in front of the ego and then analyze how the ego performs in that case. So this is a good way to add new scenes to your data set, and it's also a good way to validate how your stack is performing on previously unseen scenes if you already have a trained model. So you simply click on the actors, you can add them to the scenario, visualize their trajectory throughout the scene. In this case, just in this demo video, we missed the vehicle that we wanted to make cut in, but now we've added it in, and we can also give it the behavior that we want. We want it to cut in front of the ego. And so you'll see here how easy it is to modify the behavior of this vehicle. Again, the goal is to fill gaps in your training data set with scenarios that you weren't able to collect in the real world. Maybe those are safety critical cases that were unsafe to collect. Maybe there were cases that you just didn't find in your driving. And so that's the aim of this tool. You can parameterize this as well to create a few different variations if you'd like, or you can set default, you can set single values to kind of have more deterministic scenario, but you can create multiple different variations of the same kind. So I can create this vehicle cutting in at different times in front of the ego with different speeds, different amount of lateral shift. And so I can create a large number of training examples just from one log. Once we're done with the modification, we can just preview how this acts, how this will play out in the environment. And once we're satisfied with that, we can add this example to our training data set. So you'll see here, it just plays through. Only the few actors that we added from the original scene are there. And you can also have a very handy compare feature, which lets you understand what's different about the scenario that you generated versus the original. So you'll see the original trajectory in blue and the new trajectory here in purple. One of the neat things, once you've added this to your data set, let's say you want to test how this reacts. So we can skip through some of this just in the interest of time. But I want to kind of show how we would render this, something like this. So again, this is the same scenario that we edited before. In this case, you'll see that the red vehicle performs a cut-in, and we're actually able to test out how the Alfa Romeo driving policy reacts in this case. You can see that it took a different action based on the fact that the ego vehicle was cutting in front based that this red vehicle was cutting in front of the ego, and it changed lanes to avoid a collision. So that's kind of what I wanted to share, how Foretellix's tools can be used to modify existing logs and fill gaps in your training data set, and also visualize with the help of tools like AlpaSim, and in this case, NeuRec, the result of those variations. I'll hand it over to Itai now to kind of go over the NVIDIA technologies that enable these variations and the rendering behind them.
Thank you, Ron. I'll share my screen. Can you see it? Perfect. All right. Thank you, Roger, as well, for inviting me, and Dan for the great show of Voxel. I'm going to talk a bit about the technology behind what Ron and Dan mentioned. What we see in the market is that, to set the stage, is in AV we see a clear shift towards Gaussian-based simulation and generative simulation. We all know AV industry started with graphic-based simulation, which is a very deterministic simulation method, but it's very hard to scale it. Gaussian based, on the contrary, is very easy to reconstruct entire environments and create millions of simulations, but at the same time have challenges in generating environments that were never observed in the real world, because you're always dependent on an input. And generative world simulation is the next frontier that I'll talk about here. So slightly about NUREC. What is NVIDIA NUREC? NVIDIA NUREC is our Gaussian splat simulation, Gaussian splat technology for AV developers. In a nutshell, what it does, it takes recorded sensor data and generates a 360 reconstruction of the environment. You can imagine little blobs, and if you take millions of them, in this case roughly 2-3 millions, you can now describe environments. And what's great about it, and Rohan mentioned it, is that you can now do manipulation to the scene that you observed in the real world. So you can change the intrinsic parameters of your camera, the extrinsic parameters of your camera. But even more interesting, the developers can change the agents' positions and the agents around them positions, which means that now from a single scene that we observed in the real world, we can create variations of them that can be used for either synthetic data generation or testing. What you're seeing here, by the way, is not a real-world drive. That's a simulation. It's a reconstruction of a real-world drive, but that's a simulation. So you can see as well the real-to-sim gap questions that we had before have changed. So technology is really maturing. The way we build our products at NVIDIA with NUREC, we try to build it as modular as possible, and it all starts with the lowest level that we can get to, which is the CUDA and Slang kernels that we accelerate. On top of them, we released a lot of our libraries already to GSplat that developers can use. And on top of them, we released what we call the NUREC reference container, which is our implementation for reconstruction and rendering that developers can take and leverage. We have open source applications that are leveraging our technology, but we're also very happy to work with ISVs and companies like Foretellix and Voxels that adds a lot of value to the ecosystem and to developers and leveraging these technologies. We also have models that I'll cover in a second, dataset that both Ron and Dan mentioned, and some physical AI skills. The first model that I want to describe is Fixer. Fixer is a model that is based on Cosmos. Any Gaussian simulation that developers use have an inherent problem in it, which is the moment you deviate from the original trajectory of a scene, you'll start to get the artifacts in the Gaussians. So you can see here how the lane line starts to fade. NUREC Fixer, as I said, based on Cosmos, and it fixes these artifacts both during reconstruction and or only during rendering. So what you're seeing here, that's a result that we're getting after doing all of the applying Fixer both in reconstruction and rendering. This is available on Hugging Face and with commercial license. The second thing is Asset Harvester. One of the biggest challenges with graphic-based simulation was creating the assets. So we've released a system of 5 models working together that can generate a 3D asset out of a single image, meaning that you don't need to even see the entire views, entire angles of the asset, and can create the entire 3D object out of a single image. And what we're showing here on the right is an example where we took a simple, not something sophisticated intersection scenario that happened in San Francisco, and we injected scooters. I'm sure it's more laggy on your side, so I'll stop it. In the important piece, we basically added these scooters that are driving through the scenario. And this can be extended to other assets as well. In this case, we injected motorcycles that are crossing the same intersection that we had. And you can imagine the manipulation, the amount, the multiplies of how many scenarios you can create with this. One of the challenges, though, when you inject assets from one scene to another, you'll have lighting and shadows not matching. So we've built a model named Harmonizer, which harmonizes all of the shadows, lighting, and ISPs of the injected assets, and you can see the results here. What's nice about it is that you can start do extreme novel views, meaning you can create views that were never observed in the real world and fix them. So what we're doing here, the original scene was just driving straight, and in simulation we did a U-turn. And of course, the first result you'll see is not good because it's an error that was not observed in the real drive. When applying Harmonizer, though, we can start getting very good results, which means we can now extend to environments that we've never even driven in, as long as it's close enough to where we started. I'll mention briefly, everything that I mentioned is available, and we're very happy to work with Foretellix and Voxel on the integration, and you can find all of this stuff online as well. Cosmos. So at Computex and CVPR, we released Cosmos 3. Cosmos is a platform that for generative simulation. It has skills, it has different workflows, and of course, the core of it is Cosmos 3, which is the new generative model that we've released a few weeks ago. It's an Omni model, which means we used to have Cosmos Reason, Cosmos Transfer, Cosmos Predict. We're merging everything into a single model that is able to have different inputs and different outputs. What it means is that a developer can use text as an input and generate video as an output, or for example, use action and image as an input and generate videos as an output, and that's OmniTrims that I'll talk in a second. It comes with two variants, Cosmos Nano and Cosmos Super, and it's available on Hugging Face. We also have NIM available on NGC, which are optimized, containerized versions of these models. So it's a single model, means that you can use it for different things, and Cosmos can be used today for reasoning. Think about labeling. I think then show it a bit. Generate image and video data, and that's what we'll focus today. Simulate worlds, or be the actual policy for the robot itself. So this is examples on what can be done with transfer capabilities. We'll soon have a multi-view variant as well, which will be able to generate more than a single image, which is very important for AV. But the core of Cosmos Transfer, the capability of having a transfer, is the ability to go from one channel view, for example, a semantic map, as you see on the bottom left, into the pixel level. But it's interesting because what you can also do on the right, what we're showing is to combine both image and video and generate a new variant. So what's great about it is that Cosmos transfer capabilities allows developers to take an existing data that they have and extend it and augment it to variations of different weather, different time of day. And if you connect it with Nurg that we've talked before, you can do variations of even camera positions and then augment that with Cosmos. So you're really you're maximizing to the fullest all of your data sets. This is another example that Foretellix did. A lot of developers don't even have pixel level sensor data. So what Foretellix showed here is taking object level simulation and generating a pixel level scenarios out of them. And what you're seeing here, of course, is very hard to generate to collect in the real world crash video. So this is a great example by Foretellix. I want to cover for a second OmniDreams. OmniDreams is the next generative simulation, and we just released it at CVPR. OmniDreams is a real-time simulator. What it means, it can generate frames in real time and connect to a runtime, in this case Alpacim. What's strong about having a simulator like that is to generate scenarios that were not observed in the real world. And what you're seeing here is the exact example for that. The moment you're turning right to an environment that was not observed in the real world, OmniDreams really shine and can hallucinate and generate things that we didn't see in the real world. Some other examples, we can generate construction worker inserted into a scene, or changing it to snowy scene, or changing it to a nighttime, or even more interesting, we can add an elephant to our road, right? It doesn't happen normally, but sometimes it happened to me once when I went to a safari. So it might happen. And this is really everything that I started with the beginning, graphic-based NUREC and Cosmos generative simulation really provides developers the full capacity of testing and training their stack against scenarios that are observed in the real world and not observed in the real world, but your stack need to be adhering to them. I'll close with one more thing. We've released at CVPR also a lot of skills for our tools. These skills can be used to use NUREC, for example, or use Cosmos, or using Isaac Sim, and developers can take them and build on top of them, and they're available on GitHub. There's the QR code on the left, but you can Google and you'll find it as well. We're very happy to work with the ecosystem. Foretellix and Voxel bring a lot of value to the market in both expanding the AV simulation capabilities and running simulation for customers, or Voxel auditing and reconstructing the environments. And we're happy to work with other ecosystem partners as well. Thank you.
Thank you, Itai. And I think you all agree that now we have an answer to that question. What will happen if an autonomous vehicle meets an elephant in suburban USA? So at least we know that it's being tested. It's important. We should know that. always troubled me. No, but seriously, I think this is really interesting, and seeing all the tech in action certainly made the end-to-end flow come to life. And there's different approaches. We've seen some different approaches from Voxel and from Foretellix, and how it's complemented with the technology that NVIDIA is bringing to market. But I'm hoping you all felt in the audience that you're starting to see how all the pieces come together. We've got some questions from the audience. So Itai, maybe we can start with you. The question came in: how do world models play a role in both training and testing of physical AI?
Yeah, so alternative world models have become in the past few months a big word that some see Gaussian splats a part of it, and some see them not. But I'll say for both NUREC and Gaussian splat, for the first time ever, since the last 2 years, since 2 years ago, we can actually simulate millions of simulations, and these numbers will grow, I'm confident, into the hundreds of millions, if not billions. So the first thing that world models can help you is test your stack, and this stack is today AV, but maybe one of you here in the webinar is developing another embodiment, so that can be used for that as well. The second thing is for training, and here it's both for imitation learning and RL. So imitation learning, all of the data that we're generating with Cosmos or NUREC can be then fed into a traditional imitation learning pipeline, but also for RL. So we released something called AlpaGym, which enables developers to do reinforcement learning on their data used by Cosmos or OmniDreams. So these are both two things, and for the first time, really, we're seeing it, unlocking it in a scale that we hoped for it to happen, and it's now happening.
Okay, that's good. Dan, there's a question here, basic question, I think, but it will lead into some more. What makes good synthetic data?
A great question. I almost want to answer it. I'll answer the honest question honestly. I'll answer it my own way, which is the good synthetic data. There's two main things that you're interested in, especially when we think about this video by simulation type of OmniDream style that more and more people are doing it. So whether if you're generating NUREC videos or Cosmos videos, you're feeding your simulation videos. When we think about those videos, we care about traditional computer vision. And when I say computer vision, I mean like true old school, algorithmic computer vision stuff of, do these pixels look like it came from a real camera, essentially, right? Models are really smart. They'll notice if you're capturing or blurring or ripping or any of these kind of tearing throughout your video, and it'll get very confused. And there's ways to identify if your model's staring at these like inconsistencies and things like that, right? So when we think about good synthetic data, we want to have very consistent synthetic data. And we also want to do it in a new agentic way as well, where if you see some of these kind of bubbling up of potential inconsistencies across pixels of like, hey, the computer vision algorithms of old that are cheap and fast to run over thousands of millions of videos are saying something weird is happening here, then we can send in a VLM agent that basically looks at the video and says, oh, it's weird because we hallucinated the traffic light on the back of a sign or something like that, or this car turned into a bicycle halfway through the scene or something like that, right? Which are very common synthetic diffusion-based model errors that just happen from time to time. And we want to catch these whenever we find them. I think the real best synthetic data is the one where you can do this the fastest over the most amount of data and getting the highest quality results, right? I
Yeah.
don't think synthetic data models are close to 100% perfect today. They're probably more around 50 or 60% perfect today, right? But the key part is how fast can you determine what is the good one and what is the bad one, throw out the bad, keep the good, and then continue to run more synthetic data to overall increase your data set size and quality. If you're, pushing out all this synthetic data and it's all junk, that's really bad. If you're also only generating 100 videos a day because it's too hard to check how if they're good or not, that's also bad, right? So we want to find some kind of sweet spot in the middle where, hey, we might have some junk, but I'm very easy to find that it is junk. I throw it out, and here's all my really good production stuff. We're going to push that forward.
I think that's good, but I think it's also you're talking about the quality of the synthetic data. And maybe this one's to you on this. I guess it's knowing what you need to actually test. What signals need to be tested, and the question here is to what extent they need to be tested. How do you determine that you need to move to the left, and then what speed, and so on. Cutting.
Yeah, absolutely. I think we're seeing, a growing shift in regulation, right? More and more regulation is getting approved. We've seen ISO regulations add up, and we're seeing the UN also pass new regulations on what needs to be tested for safe AV deployment. I think those are good guides. And at Foretellix, we work with our customers to come up with what is the definition, what is your ODD? What's your operational design domain? And then kind of breaking it down into levels so we understand, okay, at a high level, you need to be robust to changing lanes. Okay, you need to test, and then you kind of break that down one level further. Okay, I need to test when the lane is empty, when there's other actors in the lane, when actors are accelerating from behind me, there's pedestrians, or there is no lane to the right. What should I do? So I think the space to test is constantly expanding as we discover new long tails, right? We find elephants in the suburbs, things like that. Those are all things that are constantly being added. I think regulation is playing a big role in determining what we test. And Foretellix has also been at the forefront of that, helping pass some of these regulations and contribute to the development of standards.
Yeah, so I think everyone here today has shown the capabilities of the technology. What you're drawing attention to now is, okay, where do we apply those capabilities? And as you said, I think it was just last week that the UNECE WP29 issued their latest regulation around advanced autonomy and was talking about coverage, as you said. How do you define what is that safe space? A definition. And maybe back to you, Itai, there's a question here that I think could be relevant for you. How do you know if your synthetic data is actually helping? What signals tell you it's improving model performance versus just adding more volume and more noise, which we don't want to just create, work for the sake of work. Although I'm sure NVIDIA would love to generate GPU cycles for the sake of GPU cycles.
For
Those
sure.
have to pay the bills.
That's a super important question, and I think a question that needs to be answered before you starting any training and post-training and synthetic data generation. What do you want to improve? And eventually it comes down to the downstream task. Like, does the synthetic data that was generated actually helping to improve the stack under test? For example, in AlpaSim is a runtime simulation that we've released. We've also released a lot of some benchmarks that developers can use to test their stack on. This can be off-road, can be jerk and things like that. All of these are good metrics to assess whether your synthetic data generation helps you or not. The second thing I'll say is, because synthetic data can be used for testing, is whether that reduces the number of real world testing that you need to do, or making the cycles between iterations faster. So these are the two things that I'll say are very important, both on the downstream task and the testing cycles and testing speed and reducing real-time, real-world testing.
Okay. Is it good? And the questions come in here talking also about HD maps. So I'll just read the question. Do you use just the data collection cameras for NOREC, or are you also using HD maps to get a sense of the upcoming infrastructure and scenarios and so on? I know we've been doing some work with this. Is it just the sensors, or are you also using maps to know what's going to be coming next?
Yeah.
Sorry, okay. Who wants to go for that one?
Yeah, you can go first.
So to reconstruct a scene, you don't need to have an HD map, but in order to drive on it, then we do require OpenDrive and XODR in order to have the state of all of the agents and the ego in the scene. The same apply, by the way, with Alpamayo. We always have an HD map running in parallel for that.
Yeah, for Foretellix also, to generate the neural reconstruction, as Ita said, we don't need a map. But then when you start to try to orchestrate actor behavior and position, it does need a map to kind of ground where there's lanes, where there's other objects in the way, to prevent, kind of just noise being generated rather than actually useful training data.
Okay. Two more questions here, which just fit into our allocated hour. From Bugra, is there any end-to-end pipeline that converts raw data into NOREC ingestible data with all dynamic object labeling, etc.? Publicly available. That's the question. Is the pipeline publicly available? Starting with physical AI data sets is straightforward, but using another data set for NOREC ingestion looks challenging.
So NOREC is using a data format called NCore, which is publicly available, and that's the ingestion to our reconstruction pipeline. And we've released some converters that can be used in order to understand what is the conversion that you need to do in order to adhere to that standard. We've also released at CVPR some skills to help do it faster. So I'll urge you to just check them both, the NCore repo and the physical AI skills, where we have a skills MD to help and make these conversion faster.
Another one from Boris Filipov, and I think this one might be for you, Warren. Did you get any feedback from customers on how well the synthetic data suits either their training or their testing of the inference? How widely the synthetic data is being used in the industry? Is it yet emerging, or is it already being adopted? Well, I can also already say that we're seeing more and more happening every day, and it's definitely emerging. But Ron, you've got a lot of experience with our customers. Can you unmute?
Yes, I think let me answer the second part first. I think it has been emerging, but it's now being more and more widely adopted. I think as standards come out, as the requirements that need to be tested get better defined, we're finding that the answer is to turn to simulation, especially because there's a lot of safety critical cases that need to be tested. And some of the regulations, like JAMA, for example, are pretty abstract in their regulatory definitions. And you need synthetic data to kind of execute every variation that they require testing. So I think synthetic data is trending upwards pretty fast. On the first part, I think synthetic data is right now being used more for testing than for training. And that's in large part because a lot of our customers already have fleets of vehicles that have collected a large amount of data that they're using to train. But I think as gaps start to get identified in these larger data sets, and especially, as pertain to regulations that need to be tested, it will focus more and more on the training side as well. And that's kind of why we wanted to get this webinar out there and kind of discuss different approaches on data curation, data analysis for your training data sets, because I think all of us see that that's going to be the next step for synthetic data.
I think one of the interesting things we're seeing here and seeing it all from everything you guys have shown is there was a distinction in the past between the real world driving data and the synthetic data. And now we're seeing these really merging. You're starting with real world data. You showed this really well, Dan, how you can ingest it, you can look for it, you can search for it. And then Ron was showing how you can change it with different behavioral scenarios, and then E2E, of course, adding the whole realism on top of it to make it be able to use it to train the data set. So for me, what is really interesting and seeing this happening, and I think E2E showed actually the evolution of these algorithms, is showing how we're moving from something that they went side by side and now they're merging and they're working very, very well together. We're coming towards the end, guys. It'd be great if you have one final sentence you want to say. So, Dan, I think what would you a finishing few words?
Yeah, sure. I just want to highlight that these models are, of course, getting better, but that doesn't mean it's not highly impactful today, right? I think I don't know if it's the chat GBT-ification of this problem and how I can go online and create synthetic images and things like that, that people are very familiar with it, that this tends to be one of the more finger-waving problems in AV today. Just reminding everyone that the goal is not to make the best, most crisp, realistic video that you possibly can. The goal is to make a self-driving car, right? And so if it looks 90% like the real self-driving car, scenario in the real life, and it still knows how to drive in that scenario, and it still knows to hit the brakes and stop at the red light and all this kind of stuff, that is the goal that we are trying to capture. I say this to say, like, make sure you're having the right mindset in terms of how you evaluate the quality of your synthetic data and how you can implement it into your training and testing stacks. Don't wait until the day where it's absolutely perfect and you can't to tell the difference between your car's footage and a synthetic footage. At that point, it'll be too late because your competitors have already implemented it in. So now's a great time to start building your own synthetic data pipelines. And I think the three crews here are a great place to start.
Ron, final words?
Yeah, I think Dan said it really well. But yeah, I just want to add, I think we're seeing a big shift already from kind of going model-centric AI to data-centric AI. I think Andrew Ng's words, right? So for us as well, the focus has been a lot on data. How can we generate the best data, but best in this case, as Dan said, right? Best that's focused on furthering your goal, not necessarily this looks the best. And so, yeah, I think, with the help of great tools developed by NVIDIA and a lot of their ecosystem partners, Voxel 51, of course, and Foretellix, we're able to generate synthetic data at a scale that was previously unachievable. And I think that's been a big benefit to the industry. We're seeing big jumps in performance, very, very frequently.
And E2E?
That's great comments. I'll just amplify both what Ron and Dan said. I think the conditions are here to build, and we need the tools to be ready, and they are. We need to reduce friction, and we're reducing, and we need the ecosystem to support all of that. And I think this meeting really shows that we have all three together. Like Dan said, go build and have always, in mind what is the end goal. The end goal is never to just have a simulation. The simulation solves a problem. And in this case, it's autonomous vehicles.
Wonderful. Well, thank you, guys. I was brilliant. It was an eye-opener. And I also love the fact that, yes, anyone could see there was some overlap, but that's fine. There's a lot to do to make, as Dan said, to make autonomous vehicles safe, because that's what we want. So there's a lot of work to do. And if we can all work together and we can bring the OEM, the customers, the people who are building these vehicles, better and better technology and help them implement it safely, as Dan said, then we're all achieving the big aim that we all have. So thank you very much, guys. And thank you all of you who attended. If you signed up, we'll be sending a recording of this video, and stay long and look out on all of our social media channels, because there'll be more blogs, more webinars, more things. So thank you all. Good day, good afternoon, and good night, wherever you are.